Good evening. Good evening. Today we'll discuss 5 marks questions of integration. Of integration. We'll start from as usual March 2014 paper. Find integral dx over x square minus a square and hence evaluate integral 3x square plus 13x minus 10 dx over 3x square plus 13x minus 10. This is the problem given, and you will find almost every year the question is almost like this. They'll give you one standard limit, the integral, which you are going to evaluate. And then using this standard limit integral, you are going to work the given problem. Now let us take this 1 over x square minus a square. So if you factorize this, you get x minus a into x plus a. Partial fraction problem, a over x minus a plus b over x plus a. So multiply by LCM. It's a problem on partial fraction x plus a plus b into x minus a. Two non-repeated factors, therefore two constants. Put x is equal to a. So 1 is equal to 2a. Therefore a is equal to 1 by 2. Put x is equal to minus a. 1 is equal to, this will become 0, this is minus a and minus a, minus 2a into b, therefore b is equal to 1 by 2a. So what you can do is, this problem, or you can write this as x square minus a square only as it is, x square minus a square dx will be, what is a? A is 1 by 2a. 1 by 2a into dx over x minus a. D is minus 1 by 2a into dx over x minus x plus a. So we have substituted the values of a and b. Now we are going to integrate this. So 1 by 2a is present in both places. So let us take 1 by 2a common. This is log of x minus a minus log of x plus a. Log a minus log b is log of a by b. You know the formula. Log m minus log n is equal to log m by n. That formula we are using here. This is log of x minus a over x plus a plus c. So we have completed the first part. What is the first part? Find this, we have found out. Now using this, we have to evaluate this problem. What's the problem given? Ex over 3x square plus 13x minus 10. See, 3 is not a perfect square. So you have two options. One is either take 3 common or make x square coefficient perfect square. I would rather suggest instead of taking 3 common and making all fractions, we will multiply by 3. So this will become 9x square plus 39x minus 30. Now we are going to use the completing square method. Remember, when you want to complete the square, you should only take these two parts first. Don't look at the third part. If you want 9x square, you must have 3x. Because it's a plus sign plus 30. So you want 13. So if you write 13 whole square, 9x square you will get 39 into 2 because 2ab. So how to remove that 2? Write this as by 2. Repeat. If you expand 3x plus 13 whole square, you will get 9x square plus 78x plus 169. But I want to, this is plus. But I want 39, so I should divide this by 2. So that when I expand this and I divide this by 2, 2ab, 2 into a into b. b is 13 by 2, you get 39x. I think it's clear to you why you should divide it by 2, because we want 39x. So, but by writing like this, you have written an extra term 13 by 2 whole square that you should subtract 169 by 4 minus 30. So if you simplify this, I'm just taking 3, I'm just writing like this, integration symbol I shall write later. Let me simplify this. So this is 3x plus 13 by 2 whole square minus 4 is the LCM. So let us take minus 8 common. 169 plus 120. Why plus? Because I have taken minus 8 common. So this is nothing but 3x plus 13 by 2 whole square. 169 plus 120 is 289. That is 17 square. So you can write a 17 by 2 whole square. I would always suggest a student remember square up to 19. 12 square is 144. 13 square is 169. 14 square is 256. 15th 196. 15 square is 225. 16 square is 256. 17 square is 289. 18 square is 324. 19 square is 361. Always encourage students to remember this. So if you remember these squares, then it is going to be easy. Now, what is the problem now? You have to integrate dx over 3x plus 13 by 2 whole square minus 17 by 2 whole square. So you have this. What is the answer for this? We have got now. This is 1 by 2a log of x minus a over x plus a. Yes. That we have deduced. So we have brought this problem into that format. Now we should see what is x. In place of x, you have got 3x plus 13. Therefore, you should divide this and differentiate this. You get 3. A is, see, 1 by 3 you should take first. Why 1 by 3? Difference is 3x. You should, I have explained this in my revision classes. When you find this term is not in standard form, you should differentiate that, and whatever derivative you get that you have to divide. So 3x differentiation is 3, 13 by 2 is 0, and divide 1 by 3 into 1 by 2 a. What is a? A is 17 by 2. Log of what is x? X is 3x plus 13 by 2 minus a is 17 by 2 divided by 3x plus 13 by 2 plus 17 by 2 plus c. While revising problems using completing square method, we explain this. Or else what you should do is, supposing you are not able to remember that, you have to put 3x plus 17 by 2 as t and work it out. Instead, I have suggested a method. You have to compare with this and differentiate this. Whatever derivative you get, that you should divide. So, derivative 3x is 3, I am dividing. Now, what will happen is, these two will cancel. So, when those two cancels, what is your final answer? Your final answer is going to be 1 by 51 log of, this is 13 by 2 minus 17 by 2 is minus 2, because 13 minus 17 is 4, 4 by 2 is 2, 13 by 2 plus 17 by 2 is 30 by 2 is 50, 3x plus 15 plus. This problem carries 5 marks. So normally 5 marks questions will be like this only. They will give you a standard limit, a standard integral that you have got to integrate. Then using that standard integral, you are asked to work the problem. Sometimes problems are given in a direct format, or you have got to use completing square method in completing. So let's go to the 2000. July 2014. We'll move on to July 2014. So now we have completed March 2014. We'll move on to July 2014. July 2014. Find integral dx over x square root of x square plus a square, root of x square plus a square with respect to x, that is dx is there, and hence evaluate dx over root of x square. It's a very simple problem. Dx over root of x square plus 7. See, this is a standard limit which we have listed. Dx over root of x square plus a square is equal to log of x plus root of x square plus a square plus c. We know this. So you can, in place of a square you have got 7. So you can write x square plus 7 root 7. That is x square plus a square. That is x square plus 7 plus c. By using this, then that case will get only 1 mark. Because this they want to do. One advantage is you know the answer for this. So we can prove it. So what's the proof we have got to do? These are all standard problems you need to remember. See, whenever you have got a square minus x square, put x is equal to a sin theta. If you have got a square plus x square, put x is equal to a square plus x square. Put x is equal to a cos theta. X is equal to a cos theta. These are all methods suggested. If you have got x square minus a square, put x is equal to a secant theta. The advantage is, 1 minus x square theta is cos square theta. I'm sorry, this is not cos, this is tan theta. A tan theta. And 1 plus tan square theta is secant square theta. And here secant square theta minus 1. So this is a normally suggested. Whenever you notice a problem having a square minus x square, put x equals a sin theta. If it is, of course, the root, not otherwise. If root is not there, it's a different problem. For example, if root is not there, it is 1 by a tan minus x by a. If root is not there, it is just the way about 1 minus 1 by 2a. So when root is there, this is the method. So here x square plus a square is there. So you have what to use? Put x is equal to a tan theta. What is dx going to be? A secant square theta d theta. Now you substitute. Dx is a secant square theta d theta. Root of a square a square tan square theta plus a square. Again, x square plus a square is there. This, if you simplify, you get a secant square theta divided by a secant theta d theta. You know why? Because 1 plus tan square theta is secant square theta, root of secant square theta is secant theta. A will cancel, one secant will cancel. What do you get? Integration of secant theta d theta. So you should remember, the integration of secant theta is log of secant theta plus tan theta plus c. But what is tan theta? It is x. Tan theta is x by a. You know why? We have put x equal to tan theta. X equals a tan theta, therefore tan theta is x by a. But you have to find out what is secant theta. Secant theta is equal to root of 1 plus tan square theta. Root of 1 plus x square by a square. That is root of a square plus x square by a. So this is root of x square plus a square by a plus c. You can write this as log of x plus root of x square plus a square plus c. The reason being, if you take LCM, you are getting log of m by n, that is equal to log m minus log n. Log a is a constant. That constant you are adding to this c, then call it as capital C. I am using log of this minus log a. Log a is a constant. So constant plus constant is a bigger constant. So this is the actual result you need to remember. What's the result? Dx over root of x square plus a square is going to be log of x plus root of x square plus a square plus. Now we are going to work the problem given. What's the problem given? The problem given is dx over root of x square plus 7. Dx over root of x square plus 7. Write 7 as root 7 whole square. So x is x only, a square is a is root 7. Let us use this formula. X plus root of x square plus a square, that is 7. So in almost every year, when they give 5 marks question, they will give you a standard integral which you have got to prove it and then use the for the given problem. So we will move on to the next problem, that is March 2015. March 2015. March 2015. Integrate dx over root of x square minus a square and hence evaluate dx over root of x square plus 6x minus 7, x square plus 6x minus 7. In the previous problem I suggested, you got x square minus a square, put x is equal to a secant theta. So what you can do is put x is equal to a secant theta. What is dx? A secant theta tan theta dt. Now in place of dx you are writing a secant theta tan theta d theta divided by a square secant square theta minus a square, that is equal to a secant theta tan theta divided by a secant theta dt. So what will happen? Now here, this is a square into secant square theta minus 1. So this is not secant, it is tan theta. Sorry, this is tan theta. Because you are taking a square common, secant square minus 1 is tan square. Root of that, so root will go, so a and a will cancel. You get tan theta. Same as the previous problem, secant theta d theta. That is log of secant theta plus tan theta. Now, here secant theta is equal to x by a. But what is tan theta? Tan theta is equal to root of secant square theta minus 1. that is root of x square by a square minus 1. That is root of x square minus a square by a. So plus c is there. So this is log of secant theta is x by a. Tan theta is root of x square minus a square by a plus c. Just as the previous problem, log m by n. Log a is going to be a constant. So what the answer? X plus root of x square minus a square. Yes. So we have calculated this answer. What is this? This is equal to log of x plus root of x square minus a square. Now using this, we have to work the problem given. What's the problem given? The problem given is dx over square root of x square plus 6x minus 10. I've explained you the completing square method. Always look at the first two terms. So what do you get? You can write this as x plus 3 whole square. If you want, you can check. A square is x square, 2ab is 6x. You are getting 9 extra, subtracted 9. Then they have given minus 7, write that. So what do you get? Dx over root of x plus 3 whole square minus 4 square. Why minus 4 square? Minus 7 and minus 9 is 16. So you can use this formula. In place of x, you have got x plus 3. Then you have got other than x, you have to differentiate that. The differentiate, I get 1, therefore there is no change. 1 by, this is log of x is x plus 3 root of x square minus a square is the given problem. I repeat, though it is not in the standard form, there is no need of dividing by any number because when you differentiate x plus 3, you get 1. So with this, we will go on to, we get only one problem every year. So we will move on to July 2015. July 2000. The problem given here is find the integral of x square minus a square. Integrate root of x square plus a square, not minus, plus a square dx and evaluate root of x square plus 4x plus 6. Root of x square plus 4x plus 6. So I have given you three integrals. One is x square plus a square. Other one is x square minus a square. The next one is a square minus x square. What is the answer for this? X by 2 into x square plus a square plus a square by 2 log of x plus root of x square plus a square. This is also same, you get a minus sign here. This is also same, of course, same in the sense x by 2 into root of x square minus a square. And this is minus a square by 2 log of x plus root of x square minus a square. And this is same thing, x by 2 root of a square minus x square plus a square by 2 sin inverse x by a. These are the three standard problems. So for this we have got to use this. So if you remember this result and use it further by after completing square, you get only 1 or 2 marks. But you have got to prove this. So how to prove it? You should remember. So remember, these three problems must be proved by integration by parts. Whereas when there was a root in the denominator, we use substitution and theta and secant theta. And when there was no root, we worked out by partial fractions. So that means there are two problems there and three problems rather, without root. One of them is very easy. That is when you have dx over x square plus a square. That's a standard one by a tan inverse x by a. The other two you have got to prove it. Even for 1 by a tan inverse x by a also you have got to prove it. So remembering the substitution suggested. Then in these types of problems, you have got to work out by integration by parts. So you put u is equal to x square plus a square. This is a method. dv by dx equal to 1. What is du by dx? 1 over 2 root of x square plus a square into 2x. What is that 2x? Difference of x square. What is v here? V is x. Here 2 and 2 will cancel. So what is the integration by parts? U dv by dx is equal to uv minus integral v du by dx. Dx is the formula. So here integration of x square plus a square dx is equal to uv. uv is x into root of x square plus a square minus v is x. dv by dx is x over root of x square plus a square to dx. This is equal to x into root of x square plus a square. Comparatively, very lengthy problem. Strictly speaking, this problem deserves 5 marks. The other problems were, I feel 5 marks is too much for that. Here, at least little more working is involved. So you will get x square over root of x square plus a square dx. What is the method for this? So write this as it is, x into root of x square plus a square minus, you have to do some adjustment, x square plus a square over root of x square plus a square, put a bracket here, minus a square over root of x square minus a square dx. Here you can cancel this x square plus a square. So you are going to get x plus root of x square plus a square minus, this is same as the given problem. See, now what we do is we call that as I. Call the given problem as I. So this is going to be minus I. And minus into minus plus, a square is a constant. This problem, we can use the standard limit directly. Log of x plus root of x square minus a square plus c. So this I we are going to bring it to left hand side, it becomes 2i. 2i is equal to x into root of x square plus a square plus a square into log of x plus root of x square minus a square plus c. Now you can write the answer. If you want, I divide by 2. So x by 2 into root of x square plus a square plus a square by 2. Sorry, this is plus. This is plus, this is also plus. So please make correction, these are all plus because you got plus only here. So a square by 2 log of x plus Root of x square plus a plus c. So this completes the derivation. You will get 3 marks for this. But the problem given is x square plus 4x plus 6. That you have got to work out using this x square plus 4x plus 6 dx. You can take the first two terms. You can write this as x plus 2 whole square. By writing x plus 2 whole square, you are writing x square plus 4x plus 4. That 4 you subtract. Then write that 6 inside the root. That is equal to, finally how much you get? Plus 2. So I can write that as integrate root of x plus 2 whole square plus root 2 square dx. Because minus 4 plus 6 is 2. Now x square in place of x square I got x plus 2. Should differentiate this, no change, therefore there is no dividing many number. So you can directly substitute. In place of x you have got x plus 2 by 2. Root of whatever is given you can write. X square plus 4x plus 6 plus a square by 2. A square is 2 by 2, that will cancel. Log of, in place of x you have got x plus 2 plus root of x square plus 4x plus 6. So it's a little lengthy problem, but you need to remember when a problem of this type, x square root of x square plus a square or x square minus a square or a square minus x square is given, you have to use integration by parts. Let's move on to the next problem of March 2016. March 2016 problem. March 2016. Integrate x square plus a square dx over x square plus a square and evaluate 3 plus 2x plus x square. Evaluate 3 plus 2x plus x square. See, we know dx over x square plus a square is a standard result 1 by a tan inverse x by a plus c. We know this, but if you write directly, you will not get the marks because they want you to evaluate that. So, what substitution I suggested for x square minus a square secant x equals secant theta, x square plus a square, put x is equal to 8 tan theta. What will be dx? A secant square theta dt. See, 2014 problem was x square minus a square. That's why I am working this. So otherwise I would have skipped this. There it was x square minus a square. This is x square plus a square. So you substitute here. Dx is a secant square theta d theta. What is x square? X square is a square tan square theta plus a square. You can write this as a secant square theta d theta. Take a square common. You get tan square theta plus 1. 1 a you can cancel. The other a you can keep it outside. And you will get secant square theta over secant square theta d theta. Because 1 plus tan square. You cancel this, you get 1. Integration of d theta is theta plus 6. But what is theta? Tan theta is x by a. Theta is tan inverse x by a. So the answer is 1 by a. Theta is tan inverse x by a. So we have derived that. Now we have got to work this problem. What's the method? Completing square method. So you can write this as dx over x square plus 2x plus 3. Just to confuse you, they have given in that format. You can write this as dx over, always look at the first two terms, x plus 1 whole square you can write. By writing x plus 1 whole square, you have got x square plus 2x plus 1. Then 1 should be subtracted. Then write 3. So what do you get? Dx over x plus 1 whole square plus root 2 square. Here also, it is not in standard form, you have to differentiate this, but you get 1 only, there is no change. So 1 by a is 1 by root 2, because a square is 2. Tan inverse, what is x? X is x plus 1 divided by a. With this, we shall move on to the next problem. That is July 2016. July 2016. July 2016. The problem given is root of a square minus x square dx, and hence evaluate root of 5 minus x square what's the problem? Plus 2x. Yes, 2x only. Yeah, 5 minus x squared plus 2x. Again, I have already told you, whenever you have got expression like root of a square plus x square, or x square plus a square, or a square plus x square, you have to go by integration with parts. Put u is equal to root of a square minus x square dv by dx is equal to 1. So what is du by dx? Du by dx is going to be 1 over 2 into root of a square minus x square into minus 2x. You have to be careful. You have got minus x square minus 2x. This 2 and 2 will cancel. So you get d is equal to x. The integration by parts, I will not write the formula, you can remember the formula. uv is x into root of a square minus x square minus v du. V is x, du is minus x over root of a square minus x square dx. Now this is x into root of. So one more thing, you call the given problem a lie, because we have realized, or we have worked a similar problem a square plus x square. So we will get one more I, we are going to shift it. So you call the given problem I. A square minus x square. Now this is minus into minus plus, it becomes You write this as a square minus x square a square minus x, you keep it as it is. So what you can do is minus x square as it is. There's a minus sign, you keep the minus sign as it is. Minus x and the minus x square I'll keep as it is. I will write a square. I repeat, I want a minus sign here because I got a square minus x square. So I will not take out the minus sign. I will keep that as it is. Now I want a square minus x square. I will write this as a square minus x square. I subtract a square. Finally, it is the same problem. So what? There we had plus sign, here we have got minus sign. So what is that we should do now? Write this as a square minus x square dx minus root of a square minus x square dx plus a square is a constant dx over root of a square minus x. I have separated. What separation we have done? A square minus x square by root of a square minus x square. You will get root of a square minus x square, that is I have written here. The other term minus and the minus is plus I have written here. So this is I. I is equal to x into root of a square minus x square minus I plus this is standard limit sin inverse x by a. So this I comes here, it becomes 2i a square minus x square plus a square sin inverse x by a. But we want I, so divide or send this to right hand side. You get x by 2 into root of a square minus x square plus a square by 2 sin inverse x by a. See whether it is clear. So what you can do is the problem given, you have got to work it out using this formula. The problem given is integrate root of 5 minus x square plus 2x. 5 minus x square plus 2x dx. You write this as root of 5 minus x square minus 2x dx. Because when I take my x square common, I should write minus 2x. When I simplify, I'll get plus 2x. Now, again completing square method. 5 you keep as it is. This you can write as x minus 1 whole square. When you write x minus 1 whole square, you get x square minus 2x. One extra you are getting. Subtract that 1 and close this dx. So if you simplify this minus 1 will become plus. It is root of 6 minus x minus 1 whole square. That you can write it as 6 is written as root 6 whole square minus x minus 1 whole square. Now this is standard form, and though it is x minus 1, the differentiate you are going to get 1, no change. So you can write the form, use that formula. In place of x, you have got x minus 1. X minus 1 by 2 into root of 5 minus x square plus 2x plus a square by 2. A square is 6, 6 by 2 is 3, sin inverse x minus 1 by root 6 plus. That is July 2016. We'll move on to March 2017. So they have repeated all the problems. They have given x square plus a square. They have given a square plus x square. In July 2016, March 2017, they have given other left-out problem. In 2015, we have got x square plus a square. In 2016, we got July root of x. I repeat, in 2015, we got root of x square plus a square. In July 2015, we got a square minus x square. What is left over is x square minus a square. So it's a similar problem. I just want to work this problem so that you will have the total working of all types. So what is the method? How to find the integrate this? Integration by parts. So we will go for March 2017 problem. So 3 years they have repeated all the 3 problems. All problems you have got to work by integration by part, that you should remember. So the problem is integrate root of x square minus a square dx. This problem is different. Completing square method is different. X square minus 8x plus 7. X square minus 8x plus 7. So put u is equal to root of x square minus a square. dv by dx is equal to 1. So what is du by dx? 1 over root of x square minus a square multiplied by derivative of x square is 2x. 1 over 2 root. This 2 and 2 will cancel. What is v? V is x. So integration of root of x square minus a square dx is equal to uv x into root of x square minus a square minus v into du by dx. So this we are going to multiply. We will get x square minus a square. I am writing it directly because this is the third problem we are working. So what is the adjustment you should do? X square minus a square. Here, okay, call the given problem I. That's very important. Call this as I. You write this as x square minus a square plus a square. You write this as x square minus a square plus a square. So divide this by the term x square minus a square. Have a separate limit for this dx over x square minus a square. I am adding a square and subtracting a square. Here what will happen is this will cancel. You will get root of x square minus a square. So x into root of x square minus a square. This is nothing but I. And what about this? Log of x plus root of x square minus a square plus c. So 2i is equal to x into root of x square minus a square plus a square log of x plus root of x square minus a square plus c. So what is the given problem? Solution is x by 2, because you have got 2i, shift hand to the right hand side, x square minus a square plus not plus. There's a minus sign here, therefore this is going to be minus into plus. So put a bracket in the beginning, afterwards multiply by minus sign, get minus sign here. So this is minus. I repeat, though I am adding a square and plus this minus a square and plus a square, there is a minus sign outside. So when you multiply that, you get minus a square. So minus a square by 2 log of x plus root of x square minus a. Repeat once again. Here we have written minus a square plus a square, but there is a minus sign outside. Therefore, this will become minus a square. This is minus I only. Now, what's the problem given? X square minus 8x plus 7. We have to work that problem using this standard limit, standard integration, standard results of integration. Integrate x square minus 8x plus 7. Root of x square minus 8x plus 7. Always look at the first two terms. So what you get? X minus 4 whole square. Why should I write minus 4? Because I want x square, there's a minus a, minus 4. 2ab is minus 8x. And you are getting 16, subtract that 16, then write that 7. So what will happen now? This is equal to integral of x minus 4 whole square minus 3 square, because you get minus 9. Same, can use the formula x minus 4 by 2 into x square minus 8x plus 7 minus a square is 3 by 2 log of x is x minus 4 plus root of x square minus 8x plus 7. So all the three problems of, repeat that, the problem is x square plus a square dx, other one is x square minus a square dx, the third one is a square minus x square dx. These three problems, for the standard result, you have got to go by integration by parts. What were the other three problems? Dx over root of x square minus a square, dx over root of a square minus x square, dx over root of a square plus x square. You have to go by substitution. X will be a tan theta, here secant theta, here a tan theta. So depending on that, you have got to take substitutions. So these three problems we have completed. So out of the 6, anyone can be asked. Even without root also they can ask. Without root means you have got these three problems. X square minus a square, x square plus a square, and a square minus x square. All these three things, these two are going with partial fraction, this you are going with substitution. Put x equals a tan theta. So we have covered all the 6 problems. So they repeat any one of the 6. All the 6 we have completed. So what I will do, if I get a similar problem, I will not prove the evaluation process. I will avoid because I have done it. I will only take the problem and work it out. See, in 2017 July, they have made the problem very simple. They have made it very easy. They have given the problem root of a square plus x square and evaluate root of one plus x square. You know the formula for this? What's the formula for this? We have proved in fact a square plus x square dx is equal to x by 2 into root of a square plus x square plus a square by 2 into log of x plus root of a square plus x square or x square plus x square. Just to confuse you, they are given a square plus x square. The other way they are given x square plus a square. So it just whenever a is there, you replace it by 1. So here this will become 1, this will become 1, this will become 1. I'm not going to waste time on this. The next year, they have given that is March 2018. This is July 2017. March 2018. The problem given is evaluate dx over x square plus a square. We have already worked this problem, but I work the find integral and do it. X square minus 6x plus 13. So this is, we know, 1 by a tan inverse x by a. Don't write the answer directly. I have taught a method, that's why I am skipping that. I will work the problem given. X square minus 6x plus 13 dx over x square minus 6x plus 13. I repeat, this you cannot write directly, you have got to prove it. What is the method? Put x is equal to a tan theta and work it out. We have done the problem. So this is by completing square. First look at these two terms. What do you get? X minus 3 whole square. See, thank God, in none of the problem they will give coefficient of x. Because if 2x minus 3 is given, we are going to differentiate and divide by 2. That was given only 1 year in 2014. After that, they have taken precaution to see that you are not confused. So, you directly use the method. But always remember, when it is not x square, whatever is given, you should differentiate that and divide the given answer by the derivative of that. Fortunately, all these problems, whatever worked so far, when you differentiate, you get 1. The answers are not changing. But here, when I consider first two terms, I get x minus 3 whole square. That is x square minus 6. I have written 9 extra, I subtracted 9. Then 13. So this is going to be x minus 3 whole square by plus 2 square. Because 9 minus 9 plus 13 is 4. So what is 1 by a? 1 by 2 tan inverse x minus 3 by 2 plus. Repeat, you have to derive this. I have not done here because we have already completed that. I think most of the remaining term, the proof will be definitely what we have already covered. For example, July 2018. July 2018. The problem given is dx over root of a square minus x square and evaluate dx over root of 7 minus 4x minus x square. 7 minus 4x, 4x only. Now, this I have taught you the method. Put x equals a sin theta. We have got this problem. So, let me read the answer. Dx over, have you worked this problem? I think we have done it. In case if you are not done, we should do it again. Put x is equal to a sin theta. I don't know whether I covered it or not. Let me work it out. Dx is equal to a cos theta dθ. I only suggested, but I have not worked this problem. So this is a cos theta d theta divided by a square minus a square sin square theta. That is equal to a cos theta d theta divided by a cos theta. I think we have done it anyway. I am repeating it. This is theta. But what is theta? It is sin inverse x by e. So this is sin inverse x by e. I would have avoided the proof, but I did this because in case if it is not covered. Now what is the problem given? Dx over root of 7 minus 4x minus x square. You can write this as dx over root of 7 minus 4x plus x square. Minus 4x plus, I'll take minus 8 common. Then I will complete the square. Dx over root of 7 minus x plus 2 whole square. X plus 2 whole square is going to be x square plus 4x plus 4. So I should subtract that 4. So what will happen? Dx over this minus 4 will become plus 4. So I will write it root 11 whole square minus x plus 2 whole square. I repeat, this minus why I subtracted minus 4? Because when I write x plus 2 whole square, I'm getting x square plus 4x plus 4 and 4 I am subtracting. When you take multiply that you get plus 4, therefore it is root 11. So what is the answer? Sin inverse x is x plus 2 by root 11. We'll move on to the next problem of March 2019. March 2019. March 2019. The problem is dx over x square minus a square. This you have to evaluate. You have to find this and evaluate x square minus 16. Dx over x square minus 16. This I am writing the formula directly because you already worked it out. 1 by 2a log of x minus a over x plus a plus c. I am reminding you, we have used partial fraction. Here I am writing directly because already we have done it today. So what is the method now? X square minus 4 square. In place of a, you have got 4. 1 by 2a is 1 by 8. Log of x minus 4 or x plus 4 plus c. So this you have got to do it by partial fraction. I have covered in the first part today. You can refer to that. Next, July 2000, June 2019. Evaluate root of x square plus a square. First, you have to find this. Then evaluate x square plus 2x plus 5. Root of x square plus 2x plus 5. This I have taught you to go by integration by parts, but here I will write the answer directly. X by 2 into x square plus, because I already have covered this. But you need to go by integration part and get this solution, then you have to use it. Here I am using it directly. Here I am using it directly because already I have covered this. X square plus a square plus c. So you have to complete the square here. You can write this as x plus 1 whole square. So I have to subtract minus 1, then 5. Why should subtract minus 1? To expand this, you are going to get x square plus 2x plus 1, that minus 1. So that will be x square plus 2x only. Now what is the actual problem now? It is root of x plus 1 whole square plus 2 square. So in place of x, you have got x plus 1. X plus 1 by 2 into x square plus 2x plus 5 plus a square by 2. A square is 4. 4 by 2 is 2 log of, in place of x you have got x plus 1 plus root of x square plus 2x plus 5. I'm repeating, I have written the formula directly, but in the examination you have got to work it out. I have given the method. What's the method? Using partial fraction. The factors are exponential and x plus a. And then in the first part of the today, when we started the classes, I have done that. Next, we have to move on to March 2020. March 2020. The problem is dx over x square plus a square. First, you have got to evaluate this. Because I have done it directly, I am writing the answer. Whereas in the exam, you have got to, what substitution we have suggested, put x equal to a tan theta. Now, you have got to work the problem x square plus 2x plus 2 dx over x square plus 2x plus 2. Completing square method, look at this. I will write this as x plus 1 whole square. So I will get x square plus 2x, I am getting 1 extra, that I will subtract plus 2. So what do I get now? I get dx over x plus 1 plus 1 square. 1 by a is 1, tan inverse x plus 1. Comparatively very simple problem. With this we shall move on to September 2020, because in 2020 there was no exam in the June because of corona. Yeah, 2020 it was there. In 2021 the exam was not there. 2020 we shall do it. The problem given is evaluate root of x square plus a square. I mean, find this and evaluate x square plus 4 dx. I'm not going to work this because we already have covered this. Then we move on to September 2021, because in March 2021 there was no exam. So September 2021 we will move on. September 2021. The problem given is find integral of dx over root of a square minus x square and evaluate dx over root of 2x minus x square. This you do it yourself. The answer I am going to write x sin inverse x by a plus c. But here you have got to work out by completing square. First write the problem as root of minus of x minus 2x, x square minus 2x. Now I have got to decide how much I should write here. Let us first write it as 0 only. 0 minus x square minus 2x. When I multiply, I get minus x square plus 2x. Now I want to use this completing square method. So I will write this as dx over root of 0 minus x minus 1 whole square What is x minus 1 whole square? X square minus 2x plus 1. So I should subtract that 1. So finally what I get? Dx over root of 1 square minus x minus 1 whole square. Till I get 1, I am writing it as 1 square because I have used this formula. So what is the answer? Sin inverse x minus 1 plus. April 2022. We are moving on to April 2022. So the problem is dx over x square minus a square. We have to find this and evaluate dx over x square minus 16. So you can write this as 4 square. This we have already covered. So I can skip this problem and move on to July 2022. Actually, that year the exam was held in August. So the problem is dx over x square minus a square, and you have to evaluate dx over x square minus 8x plus 5. This already we have done 1 by 2a log of x minus a over x plus a plus c. But what is the method I have suggested? That work by partial fractions. But I am using it directly here because we have covered already in the first part of the today's class. So write this as, you consider only this. I'll write this as x minus 4 whole square. When I write this x minus 4 whole square, I get x square minus 8x and I got to subtract 16. Now because 4 square is 16, then add 5. So what do I get? Dx over x minus 4 whole square minus root 11 whole square. So use this formula 1 by 2a, 1 by 2 root 11 log of x minus 4 minus root 11 over x plus 4 plus root 11 plus c. It is not x plus 4, it is x minus 4 only. X minus a or x plus a, x minus 4 minus root 11, x minus 4 plus root 11. So we will move on to next problem. This I am not going to work because already worked out. The problem is March 2023 and I will not be working this problem. The problem is root of dx over root of x square plus a square, and we are going to evaluate dx over root of x square plus 2x plus 2. The same problem we have done, x plus 1 whole square plus 1 square. Therefore, I can skip this and go to June 2024. June 2024, I am moving on. June 2024. The problem is find dx over x square plus a square and evaluate dx over 3 plus 2x plus x square. This we know, it is 1 by a, tan inverse x by a. What's the method suggested? Put x equals a tan theta. Now completing square method, I can write this as x plus 1 whole square. So I have to subtract 1, then write 3. Why subtract 1? X plus 1 also x square plus 2x plus 1. Then 1 I have subtracted, 3 I write. So what do I get? Dx over x plus 1 whole square plus root 2 square. That is 1 by root 2 tan inverse x plus 1 by root 2 plus. Then we move on to August 2024. The problem is same. This they have asked. August also same problem, but evaluation problem they have changed a bit. It is dx over x square plus 2x plus 2. They have given x square plus 2x plus 2. Very simple. You can write this x plus 1 whole square plus 1 square. Simplify this. X square plus 2x plus 1 plus 1 2. This is tan inverse x plus 1. This we shall close the class today. And tomorrow I will just discuss some of the questions in the part E which are concerning integration. Very few questions are there. And after completing that, I'll just revise differential equation, some basic ideas. Then we'll try to work out the problems from the examination paper. So as per our plan, I got 3 more classes, 22nd, 23rd and 24th. I think I must be able to complete differentiation, rather differential equations. So after completing integration, the part E questions, I'll start differential equations. I'll brief about that. Then we'll work the problems of the examination paper. With that, I'll be closing. And I'll be starting, again, I'll conduct similar classes, that means free classes on YouTube for CET. The date and all that I'll announce it later. But please circulate this information to your friends and ask them to subscribe so that they will get in advance intimation when the classes start. Thank you. Okay, we'll close the class today.